everyone. Today we are looking at chemical monitoring and management, and in this topic we will look at identifying ions. So when you have a solutions, what sort of tests you can perform to see what ions are present in your solution. So in chemical analysis, you have a solution and then you want to know whether you have a cation and anion in your solution, and again what cation and what anion are present in your solution, and there are different types of tests that you can perform to look at each of the cations and anions, and those are the tests we will look at today. So our first test would be precipitation reaction. Now what is a precipitation reaction? A precipitation reaction can be used to identify ions present in an aqueous solution. So your solution must be aqueous, otherwise you cannot use a precipitation reaction. For example, you have an aqueous sodium chloride solution and you add that to an aqueous silver nitrate solution. So in that test tube you can see you have a liquid sodium chloride solution and you're adding that to your silver nitrate solution in the beaker. And when you do that, a white precipitate forms, as you can see in the diagram, and that is sodium chloride. Silver chloride, and sodium nitrate is also formed, but sodium nitrate is present in the form of ions. So there are also sodium ions and nitrate ions in your solution which you cannot see because they're present as ions, but you can see silver chloride because it precipitates out of the solution as a solid. So that's how you can use precipitation reactions, because a solid should precipitate out from when you mix two solutions together. So this can be done using solubility rules, which can be used to distinguish whether a salt will precipitate. And what is a precipitate? When you mix two solutions together, a solid substance should come out, which is called your precipitate. Now what compounds are soluble? So all salts of group 1 metals are soluble. So if you have any compounds that contain a group 1 element, they will always be soluble. Same with ammonium salts, nitrates and acetates, chlorides, bromides and iodides, except silver, lead and mercury. What does that mean is if you have a silver chloride, it will precipitate out of your solution. If you have a lead chloride or a mercury chloride or a lead bromide and lead iodide, similarly they will precipitate out of the solution. But except these three elements, any other molecule that is bounded to chloride, bromide and iodide will not precipitate out. Only these three with chloride, bromide and iodide will precipitate out because they are not soluble. So these are your three exceptions. And all sulfates except again lead, barium, mercury and strontium should precipitate out, but every other sulfate except these four elements should be soluble. So you should not see any precipitates with sulfates again. And calcium and silver sulfates are slightly soluble. So again, calcium sulfate can form precipitate, but then again they can be soluble as well. So we should use a different test to identify calcium and silver sulfates. Now let's look at what sort of compounds are insoluble. So all carbonates, sulfites, phosphates, except those of group 1 and ammonium are insoluble. If you can remember in the previous slide, we have already seen that group 1 and ammonium salts are always soluble. Hence, the exception with carbonates, sulfites and phosphates is group 1 and ammonium. And every single other carbonate, sulfites and phosphates are insoluble. So when you put them in the solution, they should produce a solid. All hydroxides, oxides except those in group 1, ammonium, barium 2+, strontium 2+, and calcium 2+. So you have to make sure that you remember with your exceptions, because the solubility rules will not be given in your exams. You have to remember them. So you have to remember that all hydroxides and oxides are insoluble, but the exceptions are group 1 elements, ammonium, barium 2+, strontium 2+, and calcium 2+. Sulfites except group 1, group 2 and ammonium are insoluble. Now let's look at flame test. So this is another type of test that you can use to identify cations in a mixture, but the difference between flame test and precipitation is that in precipitation test, the solution you use should always be aqueous. But in flame test, you can also use solid metal to test the color of the flame. Now how does this work? Because every single atom will emit different wavelength of light when they're heated. And why is that? Now we will look at what is the mechanism followed with the flame test. So light is emitted when excited electrons return to their usual orbit and release the extra energy as light of a particular wavelength. So you have an atom. Let's say it has two shells. And this is your nucleus, so you have an electron here. Now if you provide heat to this electron, let's say we provide heat energy to this electron, the electron will jump up to energy shell with a high orbit with a higher energy. So the electron jumps up to the orbit with the high energy. It will stay there for a while, and then again it will jump back down to its usual orbit. So the electron returns to the usual orbit. So it jumps back down to its usual orbit, and when it does that, it will give out light. Because it needs to release the amount of energy it had when it was in the top orbit. So when it does that, it releases light, and every single element will have a different sort of light when the electron jumps back down to its usual orbit. As you can see in the diagram, barium will have a blue light, sodium will have a red light, and calcium will have an orange light. So every single element have their own distinct type of light when they're put in a flame. Now let's look at what sort of light different elements produce. So lithium has a carmine color, sodium's flame color is yellow, potassium is light purple, calcium is brick red, strontium is scarlet, barium is pale green, and copper is blue-green. So as you can see, all these elements will have different colors. So that means every single element has their distinct type of color, and you can definitely use flame test to see what different kinds of elements are present in your solution. Now let's look at specific cations and what sort of tests we can perform. So if you take a barium metal and you put it in a flame, it will produce an apple green color. So the color of your flame should change to apple green. And what if you conduct a precipitation reaction? So if you have, as you can see in the animations, if you have barium solution and you add sulfate solution to it, it should form a white precipitate. So let's look at the reaction. So sulfate plus barium gives us barium sulfate, which is solid, therefore it is a precipitate. And no precipitate should form with hydroxide or fluoride. So if instead of zinc sulfate solution, if you add hydroxide or fluoride solution in the test tube, no precipitate should form. Only when you add sulfate, a solid precipitate should form. Now let's look at calcium cations. So if you have calcium as your cation in a solution, if you put that in a flame, it should produce an orange-red flame color. And a white precipitate should form if you add carbonate. So again, if you have a test tube full of calcium cations and you add carbonate solution to it, you can see in the animation a white precipitate forms. So let's look at the reaction. Calcium plus carbonate gives us calcium carbonate, which is again a solid, and it is present in a solution as a white precipitate. Again, with fluoride also it forms a white precipitate, so it doesn't matter. You can test calcium with both fluoride and carbonate. So if you add carbonate, it will produce a white precipitate. Even if you add a fluoride, it should form a white precipitate. And again with sulfate as well, it forms a white precipitate if the solution is too not dilute. So the best test to actually identify calcium would be fluoride, because when you add fluoride, calcium produces a white precipitate. And you can also use sulfate, but again you have to make sure that your solution is not too dilute. Now let's look at lead. Lead forms a white precipitate with chlorine. So when you add chlorine solution to your to a solution containing lead ions, it should form a white precipitate. But so let's look at the reaction. So lead plus 2 chlorine ions should form a precipitate, which is lead chloride, and it's solid, of course, and it should be white in color. But as you can see, a lot of elements produce white precipitate. So the best test to identify lead ions would be with iodine. So if you add iodine to a solution containing lead, a yellow precipitate should form. So as you can see, a lead iodide is a yellow precipitate. So with iodine, a yellow precipitate is formed when lead ions are present. So let's look at the reaction. Lead plus 2 iodine anions forms lead iodide, which is a solid again. Now let's look at copper. Copper produces a blue-green flame. Again, if you hold the copper metal to the flame, the color of the flame should change to blue-green. And with hydroxide ions, as you can see in the animation, it forms a blue precipitate. So you add hydroxide ion and it forms copper hydroxide, which is again a blue precipitate. So you can see that there are distinct colors for some of the elements. So some of the elements produces different color precipitates. So copper produces blue, and then iodine with lead produces yellow precipitate. Also with iron, you can also test iron, and iron actually produces a green precipitate when hydroxide are added to the solution, which can also oxidize in air to form a red-brown iron 3 hydroxide. And let's look at the equation. So it's iron plus 2 hydroxide ions form iron hydroxide, which is a solid precipitate, and it should be red-brown in color if it's oxidized in air. And also, if you add acidified potassium permanganate with your solution, the color should decolorize, so the solution should become colorless. So if you have the solution and you have a green precipitate, but then you add a lot of acidified potassium permanganate, your color should become clear, so you should lose your green color. So that again you can use as your confirmation test. Now let's look at iron 3 plus. How can you identify iron 3 plus cation? So if you add hydroxide solution to your test tube, which has iron 3 plus iron, the color should change to a red brownish color, as you can see in the animation. And let's look at our equation. So iron 3 plus 3 hydroxide ions forms iron hydroxide as your precipitate, again solid. And with thiocyanide, SCN, it forms a blood red complex ion. So this can be used as your confirmation test. So when you add thiocyanide in your solution, if it changes to a blood red complex ion, it will ensure that iron 3 plus is present in your solution. So let's look at the equation. So iron 3 plus thiocyanide gives us a complex of iron thiocyanide 2 plus, and that should always be red, and this is your confirmation test. Now let's look at the summary. So if you have a solution and you add chloride to your solution, chloride ions to your solution, then if a precipitate forms, it will indicate that lead is present. If you add sulfate and a precipitate forms, then it will also indicate that lead is present, and barium or calcium can also be present. So anything that forms a precipitate with sulfate can either be lead, barium or calcium. With hydroxide, so if you add hydroxide to your solution, you will can identify lead, copper, iron 2 plus, iron 3 plus and calcium. So if a precipitate forms, it's either of these 5 elements present, but copper produces a blue color with hydroxide, iron 2 plus produces a green color with hydroxide, and iron 3 plus produces a brown color with hydroxide. Let's now look at what you will do if you have a solution and you want to identify what sort of cations are present in that solution. So your first step will be to add HCl, and if a precipitate forms, that means Pb2 plus is present. So lead is present if precipitate forms when you add hydrochloric acid. What happens if you add sulfuric acid? So if you add sulfuric acid, a precipitation forms, and that will indicate that either barium is present or calcium is present. And if you add sodium hydroxide in your solution and a precipitate forms, then you can be sure that there is copper present or iron 2 plus present or iron 3 plus present. And as you can if you should remember from your previous slides, that each of these three elements have different colors. So copper has a blue color with hydroxide, iron 2 plus has a green color with hydroxide, and iron 3 plus has a red-brown color with hydroxide. So these are the precipitates that should form, and when you add these solutions and precipitates are formed, these are the elements that should be present in your solution. And identifying cations in a mixture. So if there is a lot of cations in a mixture, then if you add HCl and a precipitate forms, again lead is present. If you add hydrochloric acid and a precipitate forms, sulfuric acid and a precipitate forms, then barium is present. And if you add NaOH and if no precipitate forms, then no copper is present. And if a precipitate forms, add ammonia and mix and centrifuge, so you will make your solution basic. So you make it basic using ammonia, and then if a green or brown precipitate forms, it will indicate that Fe2 plus is present if it's green, and Fe3 plus is present if it's brown. If the filtrate is blue, then it's copper. So you can see copper has a blue color, iron 2 plus has a green color, and Fe3 plus has a brown color, which will help us to identify which cation is present in our solution. Let's look at some of the questions to test your knowledge. Question 1 tells us, 4 students concluded that lead was present. Which student had results consistent with this conclusion? So in this question, we need to look at what precipitate did the solutions form that indicate lead was present. So what sort of anion does lead react with, and what precipitate do they form? So option A tells us that no precipitate was formed with chloride or with sulfate or with carbonate, and this is wrong. Why? Because we already know that lead forms a precipitate with all these three types of anions, so it should have a white precipitate with chloride, with sulfate, and with carbonate. So option A is wrong. Let's look at option B. Option B tells us that lead forms a precipitate with chloride. This is correct. It says lead forms a precipitate with sulfate. That is correct again. But it says lead does not form a precipitate with carbonate. This is wrong because it does produce a white precipitate with carbonate. Hence, option B is also wrong. Let's look at option D. D tells us that lead does not form a precipitate with chloride, and wrong again because it forms a white precipitate with chloride. It says that it forms a precipitate with sulfate, and this is correct because it forms a white precipitate with sulfate. And what about carbonate? It says that it does not produce a precipitate. Wrong again because it does produce a white precipitate with carbonate. Therefore, our answer is C. And why is that? Because in C, they tell us that lead forms a precipitate with all these anions. So it forms a precipitate with chloride, it forms a precipitate with sulfate, and it forms a precipitate with carbonate. Hence, our answer is C, because we know that lead forms a white precipitate with these three types of anions. Now let's move on to question 2. Question 2 tells us a student is given a sample of an aqueous solution to identify. She is told that it contains sodium, barium, or phosphate ions. So this solution can contain either of these three ions, and we need to perform tests to see which one is present. So she decides to test it by adding sulfate ions, and a white precipitate is formed. So when you add a sulfate ion, all these either of these three should form a white precipitate, and now we need to find out which one forms a white precipitate with sulfate ions. So let's look at our options. So option A tells us sodium. Now this is wrong because sodium does not form a precipitate, it remains as a salt. If you can remember from before, the sodium belongs to group 1 elements, and we have already seen in our solubility rules that group 1 elements do not form precipitates. They always remain as ions in your solution. So sodium is not the answer because it's in group 1 element and it should not form a precipitate. Let's look at option C. Option C says potassium. Again, potassium is a group 2 element, and potassium sulfate is soluble in water. Again, it will remain as potassium ions and sulfate ions in the solution and will not form a precipitate. So C is not our answer again. What about D? D tells us that it could be sodium or potassium. Now this is wrong again, because in option A and C we have already said that sodium or potassium do not form any precipitates. They remain as ions in our solution. Hence, D is not our answer. Therefore, our answer is B. And why is that? Because when you add barium to your solution, it should form a white precipitate. So barium plus sulfate should form a white precipitate, and hence your answer should be B, because in the question it says when she adds sulfate ions, a white precipitate should form. Therefore, our answer is B. This brings us to the end of this topic. In this topic, we looked at the different types of cations and what tests we should perform to identify them in our solution.